What's going on? My name is Anastasio Dalde. This is SDG Labs, and I just screwed up that introduction. Alright, let's get this party started. Check this out. We've got ourselves a container. I'm going to make this one a little bit 3D. There we go. It kind of... Gosh, what does that look like? Can't really tell. Anyway, let's see. This thing is 4 inches by 2 inches by 5 inches, and this thing is 2 inches high. These are all inches, 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 inches. Alright. First thing I'm going to do before I start the problem, actually we'll read it. Paco is again filling up a container for water for his dad. His dad asks him to fill up an empty container shown below, or above. The water flows from Paco's house at a constant rate of 2 inches cubed per second. If h of t represents the height of the water as in the container t seconds after Paco begins to fill the container, and Paco shuts off the water at the precise moment the container is full, determine the domain of h. Find the domain of h in context. Okay, so first thing I want to do is figure out the volume of this thing. How much of this stuff are we trying to fill up? Alright, well, volume is equal to length times width times height. And I'm just going to split this up into 2 regions. Here's region 1, here's region 2. So volume 1 is going to be 4 times 2 times 8. That's 4 times 2 is, or well, 4 times 2 times 5, sorry. That would be 8 times 5, which is 40. 40 inches cubed. And the volume 2 is equal to, well, that's 2 by 2 by 2, so that's 8 inches cubed. So total volume that I have, volume total, is equal to 48 inches cubed. Now, what we're going to be dealing with here is, well, we've got a rate, and so I want to figure out, my function is h of t, so it'd be like h of t. It's saying the height that water is as a function of time. And I wasn't asked to figure out exactly what that graph looks like. That's another problem. All I was asked to do is figure out the time, the domain in which this thing exists. Well, it doesn't exist for a negative time. It pretty much starts at 0. And then the question really is how long does it take to fill up that water bottle? Okay. So we've got 48 cubic inches to fill, and I'm filling it at a rate of 2 cubic inches per second. Well, I guess volume over rate will give me the time. By the way, don't confuse that with velocity. That's volume. So that's simply just 48 divided by 2. This is inches cubed. This is inches cubed per second. I have no idea why I wrote IM. Okay, there. My units are going to be in seconds. 48 divided by 2 is 24. 24 seconds. So my domain for this problem right here is between t such that it is between 0 and 24 seconds. And I think it's equal to, because at exactly 24 seconds, it's full, and then he shuts off the water. Alright, that's it. Now, what would the problem be if you started with this thing already half full? Alright, well, half full would simply mean that volume 1 nu, I'll just call it V1 prime, is equal to 20 inches cubed, because that's the amount of volume you have left over, and you still have the 8 inches over here. So your volume total prime is equal to 28. So your domain does kind of change for this graph because it's going to take less amount of time. So your domain is only going to exist, as opposed to being from 0 to 24, it would be 0 to some other number. So 28 divided by 2 is just, what is that? That's 14. So your new domain is going to go from 0 to t to 14 seconds. So this is if the bottom container is already half full, whereas over here is the top container is completely empty. So those are your domains, and that's how it changes it in context. Because I'm assuming that even though this thing is half full, you started the clock once you started filling up the water. Shoots, bro. Up out.